All right. So far, we have studied the discrete mathematics on chapter 1, set and logics. And yeah, this is our lectures, and this was a laboratory that you have used. And we have covered chapter 2, and these are the lectures. And also, I gave solutions of chapter 1 and 2 in this address. And to learn more about the solutions, you can check the presentation of the last semester's student of mine to talk about the solutions of the problems in first 2 chapters. And also on chapter 3 functions, yeah, we have covered this much. And yeah, I gave you the sample solutions of the problems in chapter 3. Review exercise problems and computational problems in chapter 3 in this web address. Now, today we're gonna study chapter 4 algorithm, and you have a web laboratory here, and I also gave you solutions. After that, we will study chapter 5, introduction to number theory. Then we will have a midterm examination. Okay. Chapter 4, algorithm. And yeah, you have a lab here, and I made all the code in this lecture note, so yeah, you can use both now. Okay, this chapter 4 consists of 4 sections, and we will start from the introductions. Okay. The terminology algorithm derives from the name Algirithms, a mathematician of the 9th century, and whose book on Hindu numerals is the basis of modern decimal notations. Originally, the word algorithm was used for the rule for performing arithmetic using decimal notations. Algorithm evolved into the word algorithm by the 18th century. This is what you're going to learn. Okay, and in chapter 4, I asked you to solve the problems in page 211 to 213. That's a self-test and computer exercises. And each of you are asked to solve at least 2 or 3 problems in Q&A and share and revise and finalize to submit your PBL report. Okay? Okay, chapter 4, algorithms. An algorithm is a step-by-step method for performing a computation or for solving a problems. Algorithms have the following characteristics. You should have an input, and you should have output. Yeah. The algorithm produces output from a set, and the output values are the solutions to the problem. This algorithm should have these 4 characters. It should have a definiteness. The steps of the algorithm must be defined precisely. Okay, and it should be effective. The algorithm, must be the algorithm. Each step of an algorithm exactly perform exactly one. Exactly, and in a finite amount of time. It shouldn't go forever. It should not learn forever. It should be done in an effective way with a finite amount of time for each step. And the algorithm should have a finiteness. The algorithm should produce the desired output after a finite number of steps for any input in a set. And also, correctness. Algorithm should produce the correct output values for each set of input values. finally, generality. The procedure should be applicable for all problems of the desired form, not just for a particular set of input values. We should give precise conditions for an algorithm. So whenever we give any input value, we should give an exact solution, or you should say that it does not have a solution. We cannot handle anyway. We should give whenever we give some input, we should give also exact solution, or we should say that it does not have a solution. Like this. So the algorithm should have a generality. The chapter starts an example of an algorithm, 1.1. This algorithm is to find the maximum of three numbers A, B, and C. So input is A, B, and C, and find the largest among these three. This algorithm. So let the first object as large, and then compare the second one with the first one. And if the second object is bigger than the first one, then print it as large, and compare that one to the third one. If third one is bigger than the earlier one, then print it as the large, and return give the output as the largest one among it. You can test it. You can with this pseudo code. I made the real Python-based code here that you can practice. You can practice in my server here, and with that code, you will see the solutions among these three. Oh no, not this one. This should work in here. That code does work in here, not in Internet Explorer. That's too old. It works in the Chrome or Firefox or Safari, etc. or others, but Internet Explorer is which is too old. So among these three, the 3 is the largest one. If you choose that, then you will see that algorithms which from that algorithm that I introduced really generated the largest number among these. If you want to add this, if you define not only 3, if you add 5 or 6, list it and give to make changes, then it will give you the one that you like to have. Anyway, so these are, and also, you can make your ID, your account in this to save your works, to submit. Next algorithm, 1.2, is finding the maximum value in a finite sequence. For example, if you not only 3, if you use this, then in this sequence, this gives us the largest element among here. If you add other numbers like this, so among these, this gives you the largest numbers. If you give the bigger numbers, then that returns the largest among these sequence. Same algorithm works to check the largest number to give us as an output. Okay, that's the simple example of an algorithm in section 4.1. Next, 4.2, examples of algorithms for searching algorithm. The first algorithm that we will present is called the linear search or sequential search algorithm. If the entire list has been searched without locating X, the solution is X. The pseudocode for the linear search algorithm is displayed as in algorithm 2.1 in here, linear search algorithm. Okay, here this procedure linear search algorithm. Okay, give the numbers, then check the size of it and list it in the order. This is very important because whenever you do learn an algorithm, we should have a proper input in a proper order to save the time for the effectiveness. Okay, that is the linear search algorithms. Yeah, if you from here, if you can check 3 is in the sixth term. Okay, it counted the locations of numbers. 1 is in the first position, and 2 is in the fourth positions like this. So that algorithm points out where the number is located. So if you know the locations, then yeah, you can give you can reorder those numbers as you need it. Next, binary search. We will now consider another searching algorithm. This algorithm can be used when the list has terms occurring in order of increasing size. Okay. The second searching algorithm is called the binary search algorithm, like this. Suppose we have this. In order to search the number 19 in the list, then we split it in half and compare this number to the 1, and so we can decide whether this number belongs to this or this side. And then split it half and compare this number to the neighborhood to decide whether this number belongs to left hand side or right hand side. And then split it to half of the 1 and then compare this number to the left hand side and right hand side neighbors to decide where this number 19 belongs. If you go in that way, then you will find where the number is located. This algorithm, binary search algorithm, can be written in a pseudo code like this. Okay, we are using floor functions like that. Okay, to compare it. And this is the real algorithm that we developed from that pseudo code, and which really works. So number 19 is the location of number 19 is 14th among these. And here for the same algorithm, if we have a 10, then 10 is in the 8th position, and 2 is in the 2nd position, and 22 is in the 16th slide. So that algorithm really works to point out where your number is located with binary search algorithm, which was written in here. Next, sorting. Sorting is putting these elements into a list in which elements are in decreasing order, increasing order. Okay. Sorting is putting these elements into a list in which the elements are increasing order. For instance, sorting the list 721459 is this. Sorting DHCAF should using alphabetical order, then produce the list A, C, D, F, H like this. The amazingly large percentage of computing resources is devoted to sorting one thing or another. Hence, much effort has been devoted to the development of sorting algorithm. This is very important step. The bubble sort is one of the simplest sorting algorithms, but not one of the most efficient. We start with the bubble sort. Suppose we have 3, 2, 4, 1, 5, and we want to use a bubble sorting algorithm to list this in increasing order. Then bubble sorting algorithm works like this. Just list out 3, 2, 4, 1, 5 on order. Compare these two, 3 and 2. The bigger number is in front of the smaller number, so change it. Compare the second one, 3 and 4. It is in the increasing order, so don't do it. Next, compare 4 and 1. It is opposite, so change it. Then compare 4 and 5. It's in the increasing order, so don't do nothing. Then we have 2, 3, 1, 4, 5 like this. Then compare the first 2 and 3. It's okay. It's in increasing order. Don't do nothing. 3 and 1, switch it. Then compare 3 and 4. It's okay. Don't do nothing. Then you have 2, 1, 3, 4, 5. And then compare 2 and 1. So this is in opposite order. So you switch it. And then next compare 2 and 3, 3 and 4, and 4. Everything's okay. So 1, 2, 3, 4, 5. Now, finally we have those numbers in increasing order. Like this. This is the bubble sort algorithm. Okay? And this is the pseudo code for bubble sorting. Okay, next, insertion sorting is a simple sorting algorithm, but it is usually not the most efficient. The input is an insertion sort, so S1 to Sn. The sequence is to sort the data in non-decreasing order. Okay, so at the ith iteration of insertion sort, the first part of the sequence will have been rearranged so that it is sorted. So insertion sort, then insert S of I plus 1 in here. Okay, so that it is sorted like this. Example 5 shows how the insertion sorting algorithm works. Suppose we have 8, 13, 20, and 27, and add S5, which is 16. We want to put this number in a right position in increasing and non-decreasing order. So it should be located in between 13 and 20. How? This algorithm works like this. Insert 16 in this. So compare this 16 and 27. So 27 is bigger and 16 is smaller. So it's in opposite order. So we change it. So move 16 to the left of 27 like this. And compare 16 to 20. 20 is bigger than 16, so it's opposite order, so it's inversed, so it's change it. So you move it to the left of 20. Then compare 13 and 16. And it is in the right order, in non-decreasing order. So it is right. So it stops. So we have 8, 13, 16, 20, and 34 in a non-decreasing order. So it's done. Okay? So the subsequence is now sorted. So this is the pseudo code for insertion sorting, which was made as a code from that pseudo code, which you see here. For example, if these are the numbers that were given, then these are with that sorting algorithm, it listed the number in increasing order, non-decreasing order like this. If you have a larger size of numbers, then still it will work. 49. Then you will, it will be automatic. You, whatever number you have, then it will give you, with that simple algorithm, will list up in increasing order. You can not only to type this here, you can call your data, big data, from website by giving the web address in here to call your data to sorting it in here. I will show it later. Anyway, time and space for algorithms. It is important to know or be able to estimate the time and space required by algorithm. It is important. Time and space required. First, best case time. The input sequence is already sorted in non-decreasing order. Okay, that will always be false. The body of while loop will never be executed. If it is already in the order, then so you don't have to do nothing. It's all done already. So no time to execute, to list it up. Worst case time, if the input sequence is sorted in decreasing order, then you have to do the while loop should learn each to compare, to switch it. So it will learn the maximum number of times it will execute. So it will give you the worst case time. Okay. Next, relaxation, the requirement of an algorithm, finiteness. If not, an operating system never terminate. So your algorithm should have a finiteness. If not, then it learns forever. So you will not have any answers from that algorithms. Determinism. Algorithm for multiprocessor machine or distributed environment are rarely deterministic. So you should make it. It's a deterministic. We should make it. Generality or correctness. Many practical problems are too difficult to be solved efficiently. So we should make an algorithm that work generally and also should produce the correct answers. With those keep in mind, we can build up an algorithm. Next, randomized algorithm. A randomized algorithm does not require that the intermediate of each step of execution be uniquely defined and depend only on the inputs and result of proceeding steps. By definition, when a randomized execute, at some point it makes random choice. In practice, a pseudo-random number generator is used. For example, the function random of I and j, this function will give us a random integer between the integers I and j, inclusively. Okay, with that, and shuffle. Yeah, this actually, yeah, it was we teachers of discrete math at our university, yeah, agreed to skip these algorithms for your midterm examinations. But I will explain you. Suppose that a sequence A is input to shuffle, then assume that the value of randoms are these. Okay. For example, if you randomly generate a number from between 1 and 5, then we could have some random numbers as 2, 5, 3, 4. What we can do is we shuffle this number is like this. With this random number, we can shuffle this randomly. How? First, okay, we start. So at the first step, first one give us the random number 2, which means the first one with shuffle with the second one. Okay, random. So switch these two. Second, j is equal to 2 give us the 5 randomly. So randomly generate choice. So change the second one to the fifth one. Then third one give us the 3. So third one change with the 3 itself. So don't do nothing. Fourth one gave us the first 4, which means, for first one, we don't have to change anything. Okay, so finally, random, random shuffle of this, one random shuttle of this could be this, with this random number generators. So that random number generator can be used to shuffle the list of numbers. Okay, so the output depends on the random choice made by the random number generators. So random number generator can be used to shuffle the numbers. You can make an algorithm and coding to do the random shuffling of the given list of the numbers like this. Next, analysis of algorithm problems, section 4.3. Okay, analysis of algorithms problems. Have you heard of the big O notations? Big O, big theta, big omega. Okay, good. Then we can finish this section. We have 10 minutes. Okay. Yes. Yeah, we will continue the section 4.3.